Imagine a lone explorer, millions of miles from Earth, traversing the dusty red plains of Mars. Its name is Perseverance, a robotic rover designed and built by NASA to seek answers to some of humanity's oldest questions. Did life ever exist on Mars? What can the red planet tell us about our own world? And could humans one day set foot on Mars themselves? To understand how Perseverance works, let's embark on a journey through its design, its mission, and the remarkable technology that allows it to operate in one of the harshest environments in our solar system. Perseverance began its journey as a collection of meticulously engineered parts, each crafted for a specific role. Once assembled, the rover weighed about 2,260 pounds, roughly the size and weight of a small car. Its body is built to withstand the temperature extremes of Mars, where the mercury can swing from a chilly -195 degrees Fahrenheit at night to a comparatively balmy 70 degrees during the day. At the heart of Perseverance lies its power source, a multi-mission radioisotope thermoelectric generator, or MMRTG for short. Unlike solar panels, which can be easily covered by Martian dust, the MMRTG relies on the steady decay of plutonium-238 to produce heat, which is then converted into electricity. This system provides about 110 watts of power, enough to keep the rover's instruments running day and night, regardless of dusty weather or the planet's long, cold winters. Perseverance's brain is a sophisticated suite of computers and electronics, shielded in a compartment known as the rover compute element. Its main computer runs using a radiation-hardened processor, similar to those found on previous Mars missions, ensuring that it can survive the high-energy particles bombarding Mars's surface. The rover's software allows it to make decisions on its own, navigating obstacles, identifying interesting rocks, and executing complex science experiments, while still staying connected to mission controllers back on Earth. But what truly sets Perseverance apart is its impressive array of scientific instruments. Mounted on its chassis and arm are a collection of cameras, sensors, and analyzers. There are 23 cameras in total, each serving a specialized role. Some, like Mastcam Z, provide panoramic high-resolution color images and can zoom in on distant features, helping scientists map the Martian landscape in exquisite detail. Others, such as SuperCam, can fire a laser at rocks to vaporize a thin layer, then analyze the resulting plasma to determine the rock's chemical composition, all from a distance. The rover's robotic arm is a marvel of engineering, stretching over 7 feet long and ending in a rotating turret. This turret houses several tools, including a drill, a close-up camera called Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, and Pixel, planetary instrument for X-ray lithochemistry, which can map the elemental composition of rocks at a microscopic scale. By extending and maneuvering its arm, Perseverance can drill into rocks, collect samples, and analyze them right on the spot. One of Perseverance's most ambitious goals is to collect samples of Martian rock and soil, seal them in special tubes, and store them for possible return to Earth by a future mission. To do this, the rover uses a coring drill to extract cylindrical samples, which are then transferred into titanium tubes inside its belly. Each tube is hermetically sealed to prevent contamination. Over the course of its journey, Perseverance aims to deposit these sample tubes at key locations on the Martian surface, creating a treasure trove for future explorers. Navigation across the unpredictable Martian terrain is another technical triumph. Perseverance is equipped with a sophisticated mobility system, 6 wheels, each with its own motor. The wheels are designed with cleats or grousers to grip the sandy, rocky ground. The rover can steer not just the front wheels, but the rear ones as well, allowing it to crab walk sideways or pivot in place. Its suspension system, known as the rocker bogie, allows it to climb over obstacles as high as its wheels without tipping over. To see where it is going, Perseverance uses a combination of cameras and a feature called terrain relative navigation. As the rover moves, it snaps images of the ground and compares them with an onboard map, ensuring it stays on course and avoids hazards like large rocks or steep slopes. This autonomy is crucial, given that signals from Earth take up to 22 minutes to reach Mars, so Perseverance must often make split-second decisions on its own. Communication with Earth is another marvel. Perseverance transmits data using two antennas, an ultra-high-frequency antenna for short-range communication with orbiters circling Mars, and a high-gain antenna to beam information directly back to Earth. Most of the time, the rover sends its messages to orbiters like the Mars Reconnaissance Orbiter, which then relay the data to mission control. This relay system allows scientists to receive images and data almost daily, keeping them connected to their robotic explorer despite the vast distance. Perhaps one of the most exciting aspects of Perseverance is its role as a technology testbed. One of its companions on Mars is Ingenuity, a small helicopter that has proved powered flight is possible in Mars's thin atmosphere. Perseverance also carries Moxie, an experiment designed to produce oxygen from the carbon dioxide-rich Martian air, a crucial step towards supporting future human missions. Perseverance's daily life on Mars is a blend of science, exploration, and problem-solving. Each Martian day, or sol, begins with the rover checking its systems and awaiting instructions from Earth. Scientists and engineers use the latest data to plan its route, select new targets for study, and decide where to collect samples. When the commands are sent, Perseverance sets off, sometimes driving only a few dozen meters, sometimes pausing for hours to analyze a particularly intriguing rock. The challenges Perseverance faces are formidable. Dust storms can obscure its cameras and coat its surfaces. Jagged rocks threaten its wheels. The cold, thin atmosphere tests its electronics and mechanical systems to the limit. Yet thanks to years of careful planning and engineering, Perseverance continues its journey, each sol bringing new discoveries and new questions. In the end, Perseverance is more than just a machine. It is an extension of human curiosity, a symbol of our desire to explore the unknown. By studying Mars's ancient rocks, searching for signs of past life, and testing new technologies, Perseverance is paving the way for future explorers who may one day follow in its tracks and set foot on the red planet themselves. Every image it sends, every sample it collects, and every mile it travels brings us closer to answering some of the most profound mysteries of our universe.